Hello everyone. Today we're doing the last video of the last section of chapter 2, which is about square roots. So today we're doing the challenge practice problems. So maybe we can even divide this video into two. We'll see. Maybe we do 1 through 6 problems in this video, and then 7 through 12 on the other one. We'll see. So let n be any whole number from 1 to 100. So it's 1, 2, 3 whole numbers, right? 1, 2, 3 all the way to 100. That is n. And then find all values of n such that 2n is a perfect square. Now, what is a perfect square? Well, square root of 4 is 2. So 4 is a perfect square because square root of 4 is a integer. So in that case, 2n is 4 is one solution. So n is 4 over 2. That's 2. So n is 2. That's one. Find all values of n. So 2 is one value, but there's so many, right? So what is a better pattern, or how can we solve these? Well, we know that 1 squared, that's 1, then 2 squared is 4, 3 squared is 9. So all these right here are perfect squares. 1, 4, 9, then we have 4 squared, that's 16, 5 squared is 25. So since n can be up to 100, 2n is up to 200. So we have to go up to 200. So 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So we're up to 100. We have to go up to 200 so that then we can figure out the solutions. So next is 11 squared, that's 121. 12 squared is 144, 13 squared, that's 169, 14 squared, that's 196, 15 squared, that's 225. So we just crossed the 200 mark. So these are the perfect squares, 149 all the way to 196. So find all values of n such that 2n is a perfect square. Well, 2n equals 1, n is going to be 1/2. We can't do that because n is one whole number. N is a whole number from 1 to 100, so the 1 cannot be. How about 4? Well, 4 can be. Why? Because 2n equals 4, n is 2. 2 times 2 is 4. So n is 2. 2 is in this range here, 1 to 100 as a whole number. So 2 is one solution. Then 9, we have 9. Well, 2n equals 9. It's going to be, n is going to be a decimal number. That's not a whole number. So basically what we have to look for is even numbers, not odd numbers. So we look at 4, 16, 36, 64, 100, 144, and 196. So 2n equals 4, n is 2, so that's one solution. 2n equals 16, n is 8, so that's another solution. So 8 is another solution. Then 2n equals 36, so n is 18. 36 divided by 2, that's 18. So 18 is another solution. Then 2n equals 64, n is 32. 64 divided by 2, that's 32. So 32 is another solution. Hopefully it makes sense for you. 2n equals 100, n is 100 over 2, or that's 50. So 50 is another solution. Then 144, 2n equals 144, or that's 72. Half of 144 is 72. And the last one, 196, 2n equals 196, or just n is 196 divided by 2, which is 98. So 98. Okay, so hopefully this makes sense, but this is the solution for number 1. Now, number 2, find all values of n such that 3n is a perfect square. So n is up to 100, 3n is up to 300. So we have to go up to 300 here. So 16 squared, 17 squared, 18 squared, 19 squared, 20 squared is 400. So we've already passed the 300. So okay, let's just do these. So if you don't know them, you can use a calculator. So 16 times 16 is 256. So this is 256. Then 17 squared, or 17 times 17, that's 289. And then 18 squared, 18 times 18, that's 324. And then 19 squared, 19 times 19, that's 361. Okay, so we passed it right here. Okay, so we look at numbers from 1 to 289. These are the perfect squares that apply for number 2. So 3n equals 1. That's not going to work because n is 1/3. It's not a whole number. How about 4? 3 times n equals 4. That's not going to work because n is going to be 4/3. That's not a whole number. How about 9? Yes, that's going to work. 3n equals 9. N is 9/3 or 3. So 3 is one solution. So 9, right? Let's do here like this. And then 16. Another thing, to know if a number, basically we're dividing these numbers with 3. So 9 divided by 3, 16 divided by 3. To know if a number is divisible by 3, you add up the numbers and see if it's divisible by 3. 6 plus 1 is 7. 7 is not divisible by 3. So no. 2 and 5 is 7. That's not divisible by 3. 3 and 6, yes. 3 plus 6 is 9. 9 is divisible by 3. So 36 divided by 3 is 12. So 12 is another solution. And then 49, 9 plus 4 is 13. That's not divisible by 3. 6 and 4, that's 10. 10 is not divisible by 3. 8 and 9, 8 plus 1 is 9. 9 is divisible by 3. So 81 divided by 3 is 27. So 27 is another solution. Then 100, that's 1 is not divisible by 3. So 100 is not. 121, that's 2 plus 1 plus 1, that's 4. 4 is not divisible by 3. 144, that's 4 plus 4 is 8, plus 1 is 9. 9 is divisible by 3. So 144 divided by 3 is, you can do it here on the side if you can do it in your head. That's going to be 4. And then 24, that's 6, right? No, 8. So 3 times 8 is 24, 4 and 2. 3 times 4 is 12, and 2, 44. 144. So it's 48. So it's 48. That's another solution. So 144. Then 169, 9 and 1, 10, and 6, 16. 16 is not divisible by 3. 196, 9 and 1 is 10, and 6, 16. 16 is not divisible by 3. 225, that's, yes, it is divisible because 2 and 2 is 4, plus 5 is 9. 9 is divisible by 3. So 225, so 225 divided by 3, that's 7. 7 times 3 is 21, and 15, 75. So this is 75. So 75, n is 75. So 225. 256, 2 plus 5 is 7, plus 6, 13. So the sum of the digits is 13. 13 is not divisible by 3, so 256 is not a perfect square. I mean, 3n is not going to be a whole number, is what I mean. Then 289, 2 plus 8 is 10, and 9 is 19. 19 is not divisible by 3, so that's it. So the solutions are 3, n is 3, 12, 27, 48, and 75. So, okay. Next, number 3, find all values of n such that 4n is a perfect square. Since n can go up to 100, 4n can go up to 400. So here, up to 400. So we check all these perfect squares here. So we're basically dividing the perfect squares by 4 to see if n is a whole number, 1 through 100. So 1 divided by 4, that's not it. 4 divided by 4 is 1. So yes, 1 is the solution. So we'll just say here, this was, that was 3, and now this is 4. So 4, then 9 divided by 4 is not a whole number. 16 divided by 4, it's 4, yes. So 4, n is 4. And 25 divided by 4, that's not a whole number. 36 divided by 4, yes, that's going to be 9. So 9, because 4 times 9 is 36. 49 divided by 4, that's not it. 64 divided by 4, yes, so that is 16. That's another solution. Because 16 times 4 is 64. 81 is not. 100, yes, it is. 100 divided by 4 is 25. 25, n is 25, because 25 for n, 25 times 4 is 100. Okay, 121, no, because 125 divided by 4 is a decimal point, it's not a whole number. 144 divided by 4, so 144 divided by 4, this is going to be 3 times 4 is 120, and then we have 24, that's 6, so 36. So 36 for 144. 169 is not. 196. 196 divided by 4. Well, we know that if it's 50, we get 200. This is one less than 50, so 49. So 49. 49. That's 196. Then 225. 225 is not. 256. Let's see, 256 divided by 4. 220. Well, okay. If we do 6 here, 6 times 4 is 24, and we have 16, so 64. So 64, n is 64. This is 256. Then 289. 289 is not. 324. 324 divided by 4. That's 8. 4 times 8 is 320, and then 4, 1 here, 81. So 81. That's 324. And then 361 is not, and then 400 divided by 4 is 100, so 100. Okay, so those are the solutions for number 3, and we have quite a few of them. Next one, find all values of n such that 5n is a perfect square. So n is up to 100, so 5n can be up to 500. So here we go 21 squared, 22 squared, until we get to 500. Let's see, so 25 squared, it's 625. So let's just compute these here. So 21 squared, 21 times 21, that's 441. So this is 441. 22 squared is 22 times 22, that's 484. 484 here, and then 23 squared is 529. And then 24 squared is 576. Okay, and so up to, we're looking for up to 500, so we're looking for square roots, perfect squares up to this number here, 484. So the number is, the perfect squares are divisible by 5 if they end on 0 or 5. So here we can quickly skim 25. 25 divided by 5 is 5, so n is 5. Then 36, 49, 64, 81, 100. The number ends on 0 or 5. 100 ends on 0. So 100 divided by 5 is 20. 121, 144, 169, 196, 225 ends on 5. So 225 divided by 5 is 45. 256, 289, 324, 361, 400. 400 ends on 0. So 400 divided by 5 is 80. 80. 441 and 484. So that's it. So those four are the values of n, such that 5n is a perfect square. 5, 20, 45, and 80. Next is number 5. Find all values of n such that 6n is a perfect square. So now n is up to 100, so 6n can be up to 600. So we're looking for perfect square up to 576. So all these 1, 4, 9, all the way to 576, such that 6n is a perfect square, and find the n. So 6n equals 1, that's not it. Equals 4, no, 9, 16, 25, 36, yes. So 6n equals 36, n is 6. So 6. 6n equals 49. No. 64, no. 81. No. 100. No. 121. No. 144. Yes. 144 divided by 6 is 24. Right? So 24. Then 169. 196. No. 225. No, basically what I'm doing is I'm dividing these numbers here as I'm going down by 6 and seeing if it's a whole number or it's going to be a decimal number. If it's going to be a decimal number, I just skip it. If it's going to be a whole number, then we write it down. So 225, no. 256, yeah, no. Because 6 times 40 is 240, and then 16 is not divisible by 6. 289, no. 324, yes. So 324 divided by 6, 324 divided by 6, we get 54. 54. Then 361, no. 400, no. 441, no. 484. Another thing you can do is 484 divided by 6. Now we get a decimal. So next is 529. 529 divided by 6. That's the decimal. 576 divided by 6. It's a whole number, 96. So 96. And that's it. So those 4 numbers. That's number 5. And let's do number 6, and then we'll do another video for 7 through 12. So 6, find all values of n such that 7n is a perfect square. So n is up to 100, 7n can be up to 700. So here we need to compute maybe a couple more, 26 squared, and let's do 27 squared. We have to cross the 700 number line. So 26 times 26 is 676. And most likely here we're going to cross it. So 27 times 27 is 729. 729. So we're looking for perfect squares up to 676, from 149 all the way to 676. We're dividing those by 7 to see if we get a whole number. And we're writing those down here as solutions for number 6. So 1 divided by 7, 4, 9, 16. 25, 36, 49, yes. 49 divided by 7 is 7. Then 64, 81, 100, 121. Let's see, 121 divided by 7, no. 144, 169, no. 196, 28, yeah, so 196, that's 28. 225 divided by 7, no. 256, no. 289, no. 324, no. 361, no. 400, no. 441, yes. 63, so 63. So we have 7, 28, 63 so far. And then 484 divided by 7, no. 529 divided by 7, no. 576 divided by 7, no. 625 divided by 7, no. And then 676 divided by 7, no. We get a decimal. So, and that's it. So those are the solutions for number 6. Okay, so we'll see you on the next video. Thank you. Bye-bye.